All right, we are looking at Unit 2 again. For some of you, this test went decently. For some of you, there's some things that you need to go over. So we're going to talk about some of these things. First order of business, this first page is just the definition difference between continuous and discrete. And I'm going to come down here to make my point to these graphs. A continuous graph has a connection. So while these points may exist on this graph, there's no connection on this right one. There's no connection on this left one. There is a connection. That makes this continuous because it continues through the points. This is discrete because only the points work. None of this in between stuff works. You can't use that. So you can kind of read through that on yourself. But that's your big difference. Continuous connects your points and goes on forever, and discrete just has points. So I'm not going to go through every one, but I do want to go through a handful of them so we can talk about it. Okay, so we have ordered pairs. You need to decide why it's a function and why this one's not a function. So if you look, there's something particular about it. Each of these x values on my left side is its own. There's no repeats, so that means I can say that every input, which is your x value, has one output. And the reason I can say that is because there are no repeating inputs, so it doesn't even matter what the outputs are. It does not matter that the y values are 5 and 7, that's acceptable. The reason over here that this set of ordered pairs is not a function, because if you look, and I've got the same input 2 times 0, but they have different outputs. And that's not real. You can't do that. Most of you did pretty decently with the mapping, so I'm going to just put this in really fast. So we go 3, 4, 5, 6, 7, and 5, 6. And 5. If I look at my table, this set of table points is a function, this set of table points is not. Again, your key for that is your x values. So over here, none of my x values repeat. So then I can say, sort of the key phrase that goes with functions. Each input has one output. Every x value does not repeat, so that means there's only one y value that goes with it. Over here, though, I've got 2 -3s, different y values. This is not a function because -3, which is an input, has 2 outputs. That's legal. Now, if I give you a discrete graph to talk about this, remember we did something called the vertical line test to make our call? That's where we would. And since it only hits each point one time, it doesn't ever hit 2, that makes it a function. Again, because each input has one output, we know that to be true. It passes the vertical line test. For the same reason, this one over here on my right does not, because if I make my line here, I hit twice. If it doesn't pass the vertical line test, it's not a function. After I think most of you did okay with, it's a good refresher for you. So again, if I have a continuous graph, anywhere that I draw a vertical line, it only hits once, but over here, already on my first vertical line, it hits 2 times. So this one is a function because it passes the vertical line test. This one is not a function because it does not pass. So this is simply just plugging in. We did well with this, so I'm going to do this really quickly. You put your x values in numerical order, so -2, 2, 3, 4, -2, -1, 0, 3. You draw your arrows. You graph them just like you normally would. And you plot your points. I would like to talk about domain and range. So actually before we do that, I want to know about this. If they give you a continuous function, you can just pick the points that you want to use on there. But I don't think we did that on the test. I don't think we gave you a continuous function to do this. If you wanted to, this is how you would do it. You would just pick points. This is technically continuous, but they gave you points, so that's pretty easy. Okay, so for a discrete function where they just give you points, domain and range is a little bit more clear-cut. Every x value that has a point on it, you're going to put. So for some people, I noticed on the test, this was a good idea. They just wrote out all of their points. So they had like -3, -2, -1, -3, 1, -1, 1, 2, 3, 1, 4, -3. And then they've got all of their points right there for you, so you don't have to figure out. So my x values, which is my domain, write them in brackets, remember, and we try to go lowest to highest if we can. -3, -1, there was 2 1s, I only need to write them one time. 3, 4, and my range, of course, that is my y values. -3 gets written twice, I don't need to do that. -2, -1, 1, 2. And then I can say that this is not a function. It does not pass the vertical line. 1 has 2 outputs. I think you can do the next one yourself, following the same patterns here. Because I really would like to talk about continuous. That's where most of us got. I think most of these you can do yourself. If you're struggling, now's a really great time to come find me and ask for help. I think a majority of you did okay on this part of the test. But what really got us was the continuous. So for continuous functions, it follows this pattern here. X is between the left value and the right value. Range is between the bottom value and the top value. So if I looked here, my leftmost value, if I start over here, move left, my leftmost value is here. My x value then is -1. My right value, start over here and move this way, is 4. And then x is sandwiched in the middle. So x has to be between -1 and 4. And it makes sense to put our values in this order because x is going to be bigger than -1, but smaller than 4. If I do the same thing with range, I'm going to start at my bottom, go up. My lowest value is -3. The top go down. My highest value is a y value of 2. And my y is sandwiched in the middle. And I can say that this is a function that passes the vertical line test. key phrase, remember each input as one output. So over here in this next one, if I follow the same pattern, if I look at my leftmost item here, it looks like it's going to be that arrow. So I'm just going to leave that blank for a second. If I go to my rightmost value is that arrow. I have arrows on both sides. That's all real numbers. I look at my range. To start at the bottom, my bottom, I'm going up, is these arrows, so I'm going to leave that blank for a second. My top, going down, that's right here. My top is 4. And then I'm just going to leave the this part blank and put the y still in the middle. And I consider it's a function, again, because it passes that vertical line test. So I'm going to write down the domains and ranges here for you. I'm hoping that you can sort of determine them yourself. If you're struggling, that's okay. Raise your hand so I can help you. Domain in this one, all real numbers, left to right. My range is also all real numbers because top to the bottom to the top, I still the arrows, and it is a function. Over here, my domain is between 0 and 4, and my range is between -2 and 2. This one's not a function. I want you to see if you can figure out kind of why that's the case. Okay, evaluating I think went decently. So basically, if I have f of 3, I'm going to plug that in for x. So we have 3 plus 10, that's 9 plus 10, that's 19. I'm going to try to put some answers here really quickly for you so that you can check yourself. The one I do want to talk about is if it looks like, it looks something like this down here where it says find f of x equals 3. Over here they give us the input, and here they give us the output. So what I'm going to do is I'm going to plug in this 3 for f of x, since that's what that equals. 3 equals -5x plus 13, and then I'm going to subtract. We get -10, -5x. So the input for an output of 3 would be 2. These are what I believe I'm getting as answers. Try these. If you're not getting the same answer as me, just do them really quick. So it's possible that I made a mistake. So raise your hand and grab me. If they give you the graph, you're simply going to look on the point for where it exists. So I'm looking for f of 1. If it's inside the parentheses like that, that's my input. So where x is 1, I'm going to find the y value that goes with it. That's 2. That's right there. Do the same thing here. F of blank equals 1. This is my output, so that's my y value. So I'm going to look at where y is 1. And I'll find the x that goes with it. That's all the way over here. That x value is 4. So over here, f of 4 is 0. And f of 2 is -2. Function of -2, but the y value is -3. And the y value, that side that is 3 is 3. Over here, we have 1. And I'm going to have 16. You're not getting those? Okay, I'm about to do a part 2 video, so the whole video won't fit on this. I'm going to finish this video up, and we'll do a part 2.